But thank you for being here. My name is Brianna Hughes. I'm one of the STEM reference and instruction librarian. I'm also the graduate student services librarian, and this is a quick introduction to systematic reviews. It's kind of a big topic. It's definitely something that could be more than just 1 hour long workshop, but we're going to do our best. If you end up having more questions or want to talk more in depth about systematic reviews, please feel free to reach out to me over email, and we can schedule a time to talk more about them. And I don't know if any of you are humanities or social science students, but just a quick note for anyone who's watching this who is, systematic reviews are really big in the health and sciences field, right? It's where they started from, and that's where most of the literature and resources are kind of aligned with. That being said, a lot of what I cover today does translate, I think, to both humanities and social sciences as well as STEM fields. So I hope that everyone finds this useful and helpful. And at the end, I also do have some special resources just for humanities and social science students. So let's get started. So here's the agenda for today. We're going to start by doing an overview of what a systematic review is, talk about the different steps of the systematic review. We'll go into some detail with each step. We'll talk about some search strategies. So how do you find the literature that you cover in your systematic review? These are going to be more advanced research methods. And yeah, hopefully some of it is new information for you all. We'll talk about some helpful tools that I know of that might be good when you're working on systematic reviews, things you might find helpful to use, including some AI tools. And then we'll wrap up with some key takeaways, resources, any kind of questions you have. But if you do have questions as we go, please feel free to put them in the chat or shout them out. So starting from the basics, what is a systematic review? Well, it's often thought of as kind of the gold standard of this umbrella called evidence synthesis. And evidence synthesis is, again, an umbrella term that covers all types of reviews. A lot of times when people are thinking of a review, the default is a systematic review. It's purpose-built to answer one precise research question. It's meant to be something that's rigorous, transparent, multiple steps, and most often team-based, so working in a group to accomplish a systematic review. Sometimes these things can take a very long time to accomplish, so think like months or maybe even years, depending on the scope of your review. But the payout is, the highest level of evidence for policy, if you're writing policy, for practice, for research, for theory. It really is kind of the gold standard for a lit review of any type. And the key ingredients of a systematic review are a predefined protocol, which we'll talk about in a second, an exhaustive search of the literature, critical appraisal, so really looking at the literature and appraising it, analyzing it, and then reproducible methods. Like much of STEM, much of science, we need to be able to reproduce the methods that we do or the experiments that we run, and the same is true for how to conduct a systematic review. So maybe backing up a little bit, thinking about evidence synthesis as a broader spectrum. You have things like an annotated bibliography. That is technically a type of evidence synthesis, probably something we're most familiar with in undergrad degrees, all the way up to systematic reviews. But systematic reviews are really kind of laser focused and result in like a meta-analysis or a structured narrative. Scoping reviews map the broader literature territory. They're great for emerging or fragmented topics. Then you've got like traditional literature reviews. Meanwhile, they tend to be more selective and narrative, and also are more of an umbrella term. So rule of thumb is, if you need to be like decision grade or publish in health or psychology or other STEM fields, a systematic review is probably the path that you should take. Otherwise, think about how much time you have to accomplish your review. Do you have deadlines? How in depth do you need to go with your research? how much time do you have, what's your scope, and what's your purpose here. And that will kind of help you arrive at a decision of what type of review is best for you. I have a link here for a decision tree that can kind of walk you through the different types of reviews and help guide you to the one that maybe is the best fit for your field of research or your specific research project. So I have kind of distilled systematic reviews down to 6 steps that we're going to go through. I definitely know that there are other ways of breaking it down, maybe something that's got 10 steps or 12 steps. But 6 is kind of what I arrived at, and I think it's a pretty good list. So the first step is to define your research question. I like PICO as my template for creating a research question. That stands for population, intervention, control, and outcome. So thinking about what it is you're trying to study, what you're trying to explore, and then break it down into its population, its intervention, the control, and its outcome. Humanities folks might use PEO, which is population, exposure, and outcome, or I've also heard of SPIDER. I think it stands for sample, phenomenon of interest, design, evaluation, and research type. So an example of this might be for urban high school students, it's your population, does daily meditation, which is your intervention, versus no meditation, that's your control, improve stress levels, and that's your outcome. So for urban high school students, does daily meditation versus no meditation improve stress levels? It has all the elements of a PICO research question. Once you've kind of generated your research question, you need to draft and then register a protocol. Your protocol covers every aspect of your review, and most of the time it's a requirement when you go to register your protocol with a review register. Formal systematic reviews absolutely have to be registered on a review register. Prospero, the Open Science Foundation, and the Research Registry are 3 examples of research registries, especially if you are working with any kind of funding from a grant or a foundation. They may have stipulations where you need to register your systematic review or your protocol. Or if you're working in a lab, your PI may have a preference for registering your protocol. It does kind of depend based on your specific situation. But it's something definitely to be aware of. I think Prospero is definitely the most well-known of the archives or registries. Open Science Foundation, or OSF, it has science, in the name, so it definitely includes any kind of scientific research, but it also has other disciplines that submit protocols to them as well. So it's kind of multidisciplinary. And Research Registry is also very multidisciplinary. So what's the whole point of registering? Why is it something that's often required? Well, it allows you to kind of set or draw a line in the sand, set your goals for your systematic review, and shows your funders, if you're working with any kind of funding, that you're serious, that this is something that you're committed to completing, to seeing through, and this is the specific research question that you have decided to answer. It also locks in your research to your name, or if you're working with a research group, to your research group's names. You can also browse registries to see what other researchers have done, but it really does kind of put you out there in the literature to say, this is a group that is working on this specific research question, kind of like a notice board. So the third step, I've kind of broken it down into 4 sub-steps. It's the part of the process that most people picture first when they think about, completing a systematic review, and that is the search for the literature. But in a systematic review, searching is not just about typing in a few keywords into a database and, seeing what comes up. It needs to be planned. You really need to sit down before you start searching and come up with a plan. Some kind of documentation that you're going to keep up with as you go. And I have some examples here on the slides. You need to think about, how am I going to reproduce this systematic review, or how might someone else reproduce my systematic review? And that's why the first thing to do is to create a plan, or what you might call a search strategy or a search log. And it's going to help you search and know how you're going to keep track of all the searching that you do. So the documentation that you make, this plan, can take a few different forms. Some people use a spreadsheet or a table in a Word document. Some people use citation managers like Zotero or EndNote or Mendeley. Some people use other specialized tools, and many people use kind of a combination of all of these. So the exact format really matters less than the fact that you are keeping track of your work, keeping track of your efforts, and that you're doing it clearly, consistently, and from the beginning. So one very helpful part of the process is creating a search log. It's where you kind of track things like which database you searched in, what search terms you used, when you ran the search, and how many results you retrieved. It may feel a little tedious in the moment, but it becomes incredibly important later on when you need to explain your methods or, rerun a search or troubleshoot why one database gave you very different results than another. It also is helpful in that you're going to be doing your literature search for months. Okay, it's probably going to take a long time. And 3 months from now, you may forget what searches you've already done. And so having a good and thorough search log will help you to not be wasting your time and running the same searches multiple times. If you're not sure where to start, the examples I have here under search strategy and a search log are a great couple different good examples. So in a systematic review, you really do need to search far and wide. This is not really the time to rely on just one or two familiar tools, databases. You can't just stick to Google Scholar and the library's website or Web of Science in Google Scholar. You really do need to search across all resources that you have access to, including the library, Google Scholar, individual databases, many databases, open access resources, and other document repositories. Part of the goal here is to be as comprehensive as possible so that you're not unintentionally leaving out or missing any important studies. You also don't want to forget things like gray literature. Gray literature is a term that includes things like reports, policy documents, conference proceedings, dissertations, preprints, and working papers. So think of gray literature as anything that's not traditionally published by an academic journal. So it's a big category, a big bucket. These materials don't always show up in the same way as published journal articles, but they are still often highly relevant. So you need to make sure to include them. In some cases, gray literature helps reduce publication bias by capturing research that was conducted, but not formally published in any kind of journal. So the big picture here is that searching for literature in a systematic review is not just about finding sources. It's about building a process of searching that is broad, that is organized, transparent, well documented, and documented to the level that someone else could understand where you searched, what you found, and why you searched in that place. So here's a couple tips from a librarian who does a lot of searching for a living. Look for books. Sometimes systematic reviews are published as books. I mentioned gray literature. You headed out. Thank you for coming. Things that get published outside of normal sources, like dissertations, policy reports, preprints. I mentioned all of those. You will need to do something called hand searching, which is where you yourself are looking through issues of a relevant journal, reference lists, conference proceedings, and other evidence synthesis papers. So instead of letting Google Scholar or a database search engine do all the searching for you, you also need to take the time and do some searching in those resources that the database search engine finds for you. Again, looking at reference lists. If there's a journal that's especially relevant to your research, looking through its table of contents in multiple issues and checking for other relevant articles that they've published, looking through conference proceeding brochures or programs, and then looking at other evidence synthesis papers and seeing what those researchers have gathered. There's a lot of AI tools that can be helpful with this step, and we'll talk more about those towards the end of our time together. And really, this is kind of the perfect time to get in touch with your subject librarian. Maybe everyone knows that there are librarians here that work with specific departments. So for example, I work with the biology department, mechanical engineering, computer science, electrical engineering, and physics. My counterpart, the other STEM librarian, Simhar Johannes, works with all of the other STEM departments. So, and then we have librarians that work with students in social sciences and the humanities fields as well. So, you know, reach out to your subject librarian. I have a list here in the slides of where you can find out who your subject librarian is and say, hey, I am getting started on a lit review. Can we sit down and talk for a few minutes to, you know, get your input or get any advice? So next comes maybe the biggest task of a systematic review, and that's screening your literature. This is kind of where you really get into the weeds with a systematic review. It also sometimes can take the longest, or most of the time it takes the longest amount of time out of all the steps. So screening involves working through those hundreds and sometimes thousands of records, those articles, those pieces of literature that you have found, and it takes a lot of patience and consistency. So this is the stage in your systematic review where you take all of that literature that you've already collected through your searches and start deciding what actually belongs in your review. So in very simple terms, this is where you keep what fits with your research question and what doesn't, and that's what you exclude. But those decisions shouldn't be, made based on instinct or convenience. They should be based on whatever your inclusion or exclusion criteria are that you established back when you were creating your protocol. So you've already thought about, what are the populations that I'm looking at? What are the interventions that I'm thinking about? What are my controls? What are my outcomes if you're using the PICO method for your protocol? So you've already established those parameters of what is included in your protocol. That's what you use to measure each of the pieces of literature that you've collected against. So to avoid bias, it's really critical that you have multiple people reviewing. Most of the time when you are working with funding, they're going to expect to see multiple reviewers, again, to limit the amount of bias that may show up. I think the standard is usually around 3 or 4 reviewers, especially if you have larger or more formal projects. Smaller teams might have fewer, 2 or 3, but 3 or 4 is really kind of the standard for larger funded research projects. But the important thing is that screening decisions are not made by just one person alone. It's usually also recommended that screening is done blind, meaning reviewers don't see the decisions that the other reviewers are making about what to keep in the pile of literature and what to exclude until you've completed your own review. And that's the time where you all kind of come together and see what everyone decided on each piece of literature. And this helps reduce the chance that one person's judgment will influence another. So screening usually happens in 2 steps. The first step is when you're just looking at titles and abstracts. This is the quicker pass. Kind of think of it as like you're just skim reading, where you scan records to identify the ones that are clearly relevant or clearly irrelevant. Once you've done a first pass, what's left, you go back and do a full text review. And at that point, you take a closer look at the remaining sources and decide whether or not they truly meet your criteria for inclusion in your systematic review. And with every other step of the systematic review, documentation is really important. You need to keep track of how many records you screened, how many you excluded, and the reasons for exclusion at the full text stage. Okay, so when you're doing that second pass, reading the entire article, you need to have documentation as to why you excluded a particular piece of literature. That documentation is what allows you to create a Prisma flow diagram, which we'll get into in a second, and demonstrates that your process for your screening was transparent and systematic. So while the screening part of the systematic review can be repetitive and time consuming, it's also one of the most important in terms of quality control. So, throughout the entire review, this is where your carefully designed search starts turning into a more focused, defensible body of evidence. There are a number of tools out there that can help with the screening portion of a systematic review. We'll talk about those at the end. So the next step, I've got 2 slides for step 5. 5A is where you extract the data. Means you're pulling out the different pieces of information you will need from each source, each piece of literature in a consistent and organized way. This is the stage where you move from not just gathering the literature to actually building a data set or evidence base that you will analyze and synthesize and becomes your final output for your systematic review. So the first question to ask is, what data points do you need to collect from each article or each piece of literature? The answer for that question should come from your research question and your protocol. In other words, don't just start copying random details from articles. You need to be intentional. Think about what information you will need later on in order to describe, compare, and interpret the studies that you included. So depending on your review, some of different data points that you might include are things like the authors of the literature, the year publication, the study design or methodology, population, participants, outcomes, methods, any kind of major findings or limitations. If you're not sure where to start, it can be really helpful to look at templates or examples from published reviews or from evidence synthesis tools. You don't need to kind of make this up from scratch. There's a lot of different examples out there. If you're not sure what type of evidence to be tracking, look for an example. So as with the screening portion of a systematic review, data extraction should be done by at least 2 people. This is important because it helps reduce bias again and catch mistakes. So maybe one person, misreads a table, and this is an important detail, or they interpret something differently than the other person. Having 2 people to extract the data and verify it adds another layer of quality control and makes the review more reliable. In terms of how you actually collect the data, there is some flexibility. Some people use a Google form or another kind of structured form so that each included study gets entered in a consistent format. Others skip the form and go straight to having a spreadsheet or a table. And they, especially if you want to be able to sort and filter and compare studies more easily. But the best tool really is the one that is organized, easy to share with your collaborators, and practical for the size of your project. So the important thing is not just to collect the information or the data, but to collect it systematically and consistently. If your extraction process is messy, your synthesis will suffer and it will also be messy. And if you want a more detailed walkthrough of this step, there's a guide here, the link on the bottom of the slide from Covidence that talks about data extraction, which is useful even if you're not using Covidence, which is a big tool in the world of systematic reviews, because it does kind of talks about so this document talks about the kinds of decisions you need to make in this data extraction stage of a systematic review. So once you have identified your final set of included studies and extracted the key data from them, the next step is to appraise the quality of that evidence, of that data that you've extracted. This is the point in the systematic review where you stop and ask, how much confidence do I have in these studies and in the conclusions that they support? Just because a study is relevant enough to include does not automatically mean it is strong or rigorous or free from any kind of limitations or biases. One of the main ways that systematic reviewers do this is by using something called a risk of bias tool. These tools can help you assess the likelihood that aspects of the study's design conduct or reporting may have introduced bias into your results. So in other words, they help you evaluate whether the findings might be distorted in ways that affect how much trust you can place in them. Okay? This step is not always formally required in every type of review, especially depending on the discipline or the review type or the journal that you're looking to submit to. But it's definitely strongly recommended because it gives you a much clearer sense of the strength of the evidence base that you are working with. And it also helps you avoid treating all studies as if they were equally reliable when they are not. Okay, so remember, appraising the quality, you're looking at the studies that you have collected in your literature search, not your own study, not your systematic review. Okay. There are a lot of different risk of bias tools out there, and the best one depends on the kind of systematic review that you are doing and the types of studies that you're including in your review. There's not a single universal tool that works in every situation. So if your review includes like randomized trials or observational studies, qualitative research, or some combination of these, the tool you choose should fit that mix of methodologies. So that's why I included here the first link, the last link where it says try this tool. That is a risk of bias. Riskofbias.info resource. It brings together a number of different tools, so you can kind of, describes all the different tools that are out there. And it can be a useful starting point when you're trying to figure out which quality appraisal tool is right for you and your project. And if you are doing a mixed methods review, one especially useful option is the Mixed Methods Appraisal Tool, or MMAT. That tool is designed specifically for reviews that include more than one type of evidence, and it can help you assess kind of the qualitative, quantitative, and mixed method studies within the same framework. So the key takeaway here is that quality appraisal is about being honest and systematic about the strengths and weaknesses of the evidence that you found. It's not necessarily about excluding every imperfect study. Oftentimes, it's more about understanding the limitations clearly so you can interpret your findings responsibly. All right, step 6, this is the last one. So you write your report. You write up your report based on the data that you've extracted. If you do a quantitative study, you'll most likely run like a meta-analysis if your studies are compatible. For qualitative reviews, there's going to be more like a narrative or thematic synthesis. I would definitely encourage you to check out Prisma 2020, the link I have here under Pro Tip 5. It is a really comprehensive and expanded checklist of the different things that you should include in your systematic review. It goes through each of these 8 sections and talks about what information do you include in the abstract. What should you talk about in your methods section? What should you discuss in your discussion section? It's a really great and comprehensive checklist. So when you publish your systematic review, transparency is non-negotiable. So you need to share everything, your search logs, your extraction sheet, all of that is going to go in your appendices. All right. Any questions? I'm going to pause for a second. If anyone has any questions about the various steps of the systematic review, now is a great time to ask them. So we're going to move on now to talking about some different search strategies or research methods that can be helpful when you're working on a systematic review. So firstly, thinking about your search terms, you need to take the research question that you come up with in step 1 from a complete sentence or a complete question down to keywords or the most basic phrases. Most databases, you all may know, and including OneSearch and even Google Scholar, are very literal. They don't work well if you put your whole question into the search box because they search for every word. Okay, so you need to kind of boil or distill your research question down into its most basic words and phrases. So here are some suggestions to help you do that. Start with the keywords. You can also brainstorm synonyms, antonyms, so opposite words. If there's a controlled vocabulary that fits within your discipline. So like with humanities people, try the Library of Congress subject headings. In health fields, MESH, medical subject headings is a very popular controlled vocabulary. You may also want to create a search string table, and I have an example of one of those linked here. It allows you to track variants, so different words that you use. So I've included a number of links here, things like a list of different controlled vocabularies and some examples, a list of thesauri, an example of a search string table. I think that's everything. Yeah. And so this is another great opportunity to work with your subject librarian. So we do this for a living all the time, develop search terms, and we kind of know what search engines and databases are going to work well with, what search terms will work well. So please reach out. We love coming up with, that's why we're so great at crossword puzzles, is because we love developing search terms. Here are some other more advanced search techniques. You may have heard of some of these, but I just want to cover them all to make sure everyone knows about them. So the first are Boolean operators. You've probably seen these before, and, or, and not. I've got a helpful visualization that's tagged here or linked here. And these kind of act as like a building block of database searching. So when you use and, it narrows your search by requiring the search engine to look at both concepts, and those both need to appear in your search results. So like if you search for climate change and migration, you're going to get results that address both topics together. Or kind of does the opposite thing. It broadens your search by linking words, synonyms, or related terms. So an example would be adolescence or teenager or youth is going to give you results that include one, two, or all of those words. And it allows you to kind of capture the multiple ways that authors might describe the same concept. So, we know adolescents, teenagers, youth, those all are used interchangeably in a lot of ways. So this way, at least you're going to capture the articles that use the word adolescent or the articles that use the word youth. And then you have not, which is an exclusionary operator. And I usually recommend that using that one carefully because it can sometimes remove any kind of relevant results along with irrelevant ones. All right. Truncation is one that I find really helpful. It's great for when you're searching for multiple versions of the same word at the same time. So it looks at the root of the word. And oftentimes when you're using truncation, you write that root and then you follow it with a symbol. A lot of times it's an asterisk. I've also seen it where it's a question mark, and each database is different in terms of what symbol they prefer for your truncation search. So an example would be if I put into a database child asterisks, it's going to return results that include the word child, but also childhood, children, childs, children's, and child. Okay. It's especially useful when you want to account for singular and plural forms, or maybe like different endings without having to type each word in separately. Wildcards are related to truncation in that they kind of accommodate for spelling variations. They are helpful when there are alternate spellings for one word. So especially when you're looking at things like British versus American English. For example, a wildcard can help you search for both behavior, spelled B-E-H-A. Of course, now I'm having to spell B-E-H-A-V-I-O-R, or the British version is B-E-H-A-V-I-O-U-R. I spelled those right. Color, behavior, neighbor. The symbol varies from database to database. Most of the time I've seen it as a question mark. So you put a question mark in the place of where that alternate letter might be. So in these examples I just gave, where you might see a U, put a question mark and it'll search for all versions of that word and its various spellings. Finally, you've got proximity searching. Proximity operators tell the database to find words that appear within a certain number of words of each other. So this is useful when two concepts are closely related, but may not always appear as an exact phrase. So the example I have here, if I typed into the search box tax N5 reform, okay, that's telling the search engine, I want to see in the results that you give me back, tax and reform appearing anywhere from 1 to 5 words of each other, right? So it would return things like tax reform, okay, where the words appear together, and also tax that has been submitted for reform, because tax and reform are 5 words apart. Okay. This can help you balance precision and flexibility in your searching. But the important takeaway here is that these techniques can help you move beyond just typing a few words into a search box, and they let you search more strategically, which is especially important in a systematic review where you want to be sure that you are being thorough, intentional, and reproducible. I've got linked here a recording of last semester's advanced search strategy, this semester, so last month's advanced search strategies workshop on our YouTube page. So if you're interested in learning more advanced search techniques or hearing more about these ones that I've mentioned, I definitely encourage you to watch the recording. We held this workshop, I think, a few weeks ago. All right, here's a couple more pro tips from a librarian for you. Another technique that becomes very important once your search gets started or gets more complex is nesting. Nesting means using parentheses to group related terms together so that the database understands how your search should be interpreted. So in that sense, it works a little like order of operations in math, if anyone remembers that from trig. It helps clarify the relationships between your terms and makes sure the database processes your query or your search in the way that you intended. I also just find nesting to be helpful for me so that when I'm crafting a search string, I can keep these relationships separate in my mind. So even if it weren't for the database preferring you to use nesting, I find it extremely helpful for kind of interpreting what it is I'm looking for. So usually the terms inside the parentheses, like I have in the example here, are linked by a Boolean operator and or not. Most often it's going to be or. So in the example I have here, social media or online platforms, and teenagers or adolescents, and impact or effect. So each set of parentheses represents one concept, and the ors within the parentheses help broaden within that concept while the adds connect them together. Hopefully that makes sense. Without nesting, the database may interpret your search differently than you anticipate or you want it to, which can lead to either too many irrelevant results or missing ones that might be important. So nesting is one of the most simple ways or the simplest ways to make a long search string more organized, more readable, and more accurate. A lot of times you may be familiar with like the advanced search option in various databases, including OneSearch. That does the same thing. So when you do an advanced search and you know how you have those separate lines for different search terms, it's doing the same thing. Not every database has an advanced search built into it. So that's why I'm telling you about nesting. And also you may not want to bother with going to the advanced search page, but it's accomplishing the same thing. The other important thing to remember is that these techniques are not, standardized across different databases. So Boolean operators are usually pretty consistent, but things like I mentioned, the wildcard symbols, truncation symbols, and proximity syntax can vary a lot. One database may use that N5 like what I had on the last slide, or they may use near spelled out \5. And others may not do proximity searching at all. I know there are a couple databases that just don't have that functionality out there. So the same is true for wildcards. I mentioned the symbols might be different. If you're curious, if you're getting ready to search in a database and you're like, I want to use truncation or I want to use wildcard symbol, but I don't know which one this database prefers. A lot of times you can find that information on the database's help page or FAQ page. So I usually will just Google like JSTOR help or JSTOR wildcard formatting help. And it'll usually take you to the page that has that information on it. And when in doubt, feel free to reach out to us and we can give you that information or help you find it. So all of our databases can be found on the A to Z database list. I think at last count, we had more than 450 databases that we subscribe to. And then you also have the virtue by being a UMBC student, you also get access to all of the databases that the other University of Maryland schools subscribe to. So you have access to more than 450 databases. The A to Z list, you can filter by subject or database type. If you're not sure which database to look at, if you're kind of new to this discipline or you want to know, I know about Web of Science, but what are some other STEM databases out there? You can visit our research guides, which I have linked here, and view kind of the most popular or the biggest databases within your discipline. I do want to make a quick note here about Scopus. It's something that a lot of STEM students have heard of before, maybe from your faculty, your professors. We don't subscribe to Scopus. We have Web of Science instead, which covers the same territory. Okay, so OneSearch is a useful aggregator, but always double check discipline-specific databases for full results and additional features. So OneSearch will capture a lot, but it doesn't capture everything that you're doing in search. All right, I'll pause again. Any questions about research methods, or anything else I've covered so far? So I'm going to share some tools that I think can be helpful with the various steps of the systematic review process. Some of these are AI tools, others are not. And I would, if you have any questions about or concerns about the AI tools and using AI in your research, please feel free to reach out and talk more. This is an area that I am really interested in. I do a lot of my own research on AI tools and their use in higher education by college students. So I'm always interested in having conversations with students about AI tools in academic research and writing. All right, so for the research question development stage, so step one of a systematic review, you can certainly use a generative AI tool like ChatGPT or Gemini or Copilot to help kind of develop that research question. Different prompts may, you may have different prompt ideas for how you might go about doing that, but these can be really helpful tools, especially if you want to know what have other people said about this, or what are some related research questions that have already been asked and answered. So when you're doing literature searching, I always tell folks that AI tools can be really helpful when searching for literature, but they should not be the only way you search for literature. Keep in mind that AI tools cannot search or give you full text access to articles that exist behind paywalls. Okay, so all the articles that we have paid to give you access to through subscriptions to our databases and journals, AI cannot always see those as results. Okay, so use AI tools for literature searching if you want to, but make sure you're also searching on your own in OneSearch, in Google Scholar, and all your databases. Some of the ones I've listed here, like Research Rabbit, LitMaps, Semantic Scholar, Connected Papers, those are literature mapping tools, and they're kind of cool. I find them helpful to see relationships between papers. you're looking to see like what's the seminal article or the seminal piece of research on my topic, you can use one of these tools to kind of help track backwards from a seed article to what's the article that all articles are stemming from. So yeah, I'm familiar with Research Rabbit and Litmaps. I know of Connected Papers. I haven't used it myself though. For the screening portion of your systematic review, Rayan is kind of the big one that's out there. It's browser-based, but there's also a desktop version. I know a lot of people use Covidence, but we don't have a subscription to Covidence. It's very expensive. So if you're in a position where you have access to that, great. But Rayan has some free capabilities, but their freemium and premium and pro versions are much less expensive than Covidence. So if you're interested in a tool to help with screening, check out Rayan. There's a bit of a learning curve to figuring out how to use it, but there's a lot of helpful tutorials I've found on YouTube put out by Rayan themselves and others. ASR Review is one that I have heard about, but I haven't really had a chance to play around with it. So I don't know kind of how it works or what it does or how good it is. But if anyone has used it, please chime in the chat to share your thoughts on it. From what I've read, people like it and they find it helpful. But I've used Rayan and I've always had good luck with that one. For data extraction, I'm not really familiar with any kind of AI tool or any, technological tool at all, really, for this step of the systematic review. If you are comfortable with Python or R or some other kind of coding language, there are definitely codes that you can get and develop to use for data extraction. GitHub is a great resource for those. So if it's something that you want to try out, check out GitHub. There's also a number of resources on campus here for helping students who are looking to learn about Python or R. But with the caveat is that with data extraction, there's no tool that's 100% accurate. So you need to really be double checking any kind of tool, whether it's AI or not, against your own observations. So Pico Portal is another one. It's not free, but it's another one that I've heard of. So, pick what fits your budget and fits your kind of the time you have to sink into learning how to use a new tool. So at this stage in the process, once you've identified the studies that meet your inclusion criteria, you need to step back. We already talked about quality appraisal tools a little bit earlier, but I wanted to supply you with a few more details about these. So different tools are designed for different types of research. The JBI critical appraisal tool is useful because it covers a wide range of study designs. They have separate checklists for randomized controlled trials, cohort studies, qualitative studies, case reports, and other types. So if your review includes different types of evidence, JBI might be a good place to get started. CASP stands for the Critical Appraisal Skills Program, is another common option out there. They're often a little more approachable and intuitive, especially for people who are newer to quality appraisal. And the questions are written in like a plain language and can help guide you through the logic of evaluating a piece of literature. There's also the Newcastle-Ottawa scale, or NOS, NOS. It's commonly used for things like observational studies, especially when you've got a cohort or case-controlled studies. So if your review is non-randomized or epidemiological research, this one is one that you might come across. But really the most important thing is to choose a tool that matches the study designs that you're reviewing and then apply it consistently. So use the same tool throughout. You want to be clear in your methods section about which tool you use and why you chose that particular one, and how the appraisal process went for you. Ideally, this is also done by more than one reviewer to reduce bias and improve reliability. Yeah, I think that's everything I want to say about quality appraisal. All right, so let's wrap up with a few key takeaways and some additional resources to share. 3 main ideas. If kind of this hopefully will kind of encapsulate a lot of what we've already talked about. First is to plan carefully and document everything. A systematic review is not something you can successfully do by relying on your own memory or just kind of figuring out as you go. Every major decision needs to be documented and tracked. How you framed your question, which databases you searched in, what search terms you used, when you ran the searches, what your inclusion and exclusion criteria were, and why certain studies were kept or removed. Good documentation makes your process transparent, but it also makes your own life easier. As a strong search log or screening log or extraction sheet helps you to stay organized and prevents you from having to recreate or duplicate your work later on. Second, transparency and reproducibility are key to the whole process. What makes a systematic review different from a traditional literature review is that it's not just, it's more thorough. It is that someone else should be able to understand exactly how you arrived at your evidence base. That doesn't mean that they would get the same exact results forever, since databases change over time, works of literature were retracted or revised, but they should be able to follow your method and see that your process was systematic, justified, and not, arbitrary. This is why protocols exist in Prisma flowcharts, and clearly reporting your methods so that folks can look at your review and see the integrity of it and be able to duplicate your work. Third is that tools can help, but they do not replace your own judgment. So there are a lot of tools that can make parts of the process faster or more manageable. Things like citation managers can help you organize sources. Screening platforms can make collaboration easier. Some AI tools can help with brainstorming keywords or surfacing related literature, but none of these tools can decide for you what your review question really is, whether a study truly fits your criteria, or whether a conclusion is valid. Those decisions still require human judgment, subject knowledge, and careful reading. So use tools to support your workflow, but don't outsource your thinking to them. If you remember nothing else from today, I want it to be this. Systematic reviews are demanding. They're very intensive because they are built on careful planning, transparency, and critical judgment. The process can be very time intensive, but those qualities are what make it what separates a good product, a good final product, from a bad one. All right. These are some resources I wanted to highlight. Cochrane, the Cochrane Handbook for Systematic Reviews of Interventions is kind of the big name for health sciences specifically, but I have found that a lot of their documentation is cross-disciplinary, especially within STEM. So definitely check out the handbook, which is available for free on their website. I've got it linked here. Prisma is another standard in the systematic review world, and they have some really helpful tools like checklists or quality reports, workflow charts. So definitely browse the Prisma website. I have not put together a resource guide yet for systematic reviews. It's on my to-do list of things to do. I hope to work on that this summer, probably. But in the meantime, there are two here that I've got linked, one from College Park and one from UNC Health Sciences Library. These are great. If you are looking for a quick bit of information or how to do a certain part of a systematic review, both of these are great resources for kind of rounding up other resources. So check out those two resource guides. For anyone here who is doing a systematic review in either the humanities or social sciences, I wanted to provide some resources specifically for you because so much of systematic review talk is about STEM. But for methods and handbooks, I definitely recommend EPPI Center Methods for Conducting Systematic Reviews. Cochrane has another version of their handbook for qualitative evidence synthesis. And then the Campbell Systematic Review Guide is an open access journal that publishes systematic reviews within the social sciences. So if you're looking for like examples of what a systematic review in social sciences looks like, or if you're wanting to publish one of your own, that's a great resource to check out. Ramses 2, I've got that on the bottom right covers reporting standards for other kinds of synthesis and theory drive evaluation. And then there's also some good toolkits, the registration form for OSF and that sort of stuff. All right, we've got time for maybe a couple questions. Feel free to put something in the chat. I've got some more links here, how to get in touch with your librarian or find out who your subject librarian is. All of our workshops are listed on MyUMBC. Most of them have already happened, but all of the recordings for them are available on YouTube, which is youtube.com/UMBC library. I've got a link to the slides here if you want to save that tiny URL. And then we do have a feedback form for this workshop if you wouldn't mind sharing your thoughts on how this went. You can grab the QR code or click on that link there. We do have another grad skills workshop coming up this semester on Monday, April the 20th from 4 to 5. It's called Managing and Organizing Your Research. And we go into depth about how to kind of stay on top of a long research project. We talk about things like a research plan, citation management tools, different types of documentation. So if you're doing a systematic review, it would be a really helpful workshop to check out. So you can click on that link there to register for that one. What questions can I answer for you all? All right, well, if there's no questions, it was nice sharing all this information with you all. Thank you for coming. Bertha, did you have a question? Yeah, go ahead.
Yes, I wanted to find out, hi, how are you doing, Brian?
I'm good, how are you?
Great. I wanted to find out, is it possible to send it to our emails? Besides going to YouTube, you say youtube.com, we should, to get the recording or the materials,
Yes,
so that I can go over it.
For
My email.
this workshop, I'll send out a link in a couple of days to the recording. I can also share out the slides. So yeah, I can do that for sure.
To my email. Okay. Should I put my email in or you have my email?
I do have it from where you registered on MyUMBC.
Yes, if you can send it.
Yeah, I send it to everyone who's registered. Like I did earlier today, reminding about the workshop. I'll send the recording and the slides out to the same group of folks.
Okay, I did not receive any email. Anyway, I don't. Maybe I'm not in your link yet.
Yeah, that was a couple hours ago. It was just a reminder that the workshop was happening today. But I do have your email address, and I'll send the recording and slides out.
And for any future workshop, it's very educative. I think I would like to follow up on that.
Yeah, feel free to send me an email or reply to the one that I'm going to send you with your question about our workshops. They're always listed on MyUMBC. So if you're on MyUMBC, follow the library, and under our events page are all of our workshops. You can register for them like you did this one, get updates on our workshops, that sort of thing.
Okay, that's fine. I don't know. I will check it on the website too. Have a blessed day. Thank you.
Yeah, you're welcome. Any other questions? All right, well, thank you all so much for coming, for being here. Like I said, I will send out an email in a few days with a link to the YouTube page where you can, the YouTube recording that we share, the slides, and please feel free to reach out if you have any questions or want any help with a systematic review. We would be delighted to help you. So thanks so much.
Thank you too. Okay.